Sample 7-1 is lifting a book, and as usual, we're going to start easy. How much work must you do to lift a textbook with a mass of 2 kilograms by a vertical distance of 5 centimeters? Note, you lift the book at a constant speed. So we've got a mass of 2 kilograms that we're going to lift a distance of 5 centimeters. I'm just going to immediately convert that to meters so that I don't forget later. We're told that we're lifting the book at a constant speed. So what that allows us to do is realize that the net force on the book is 0. So if I were to draw a free body diagram, and they're not always required, in these problems, but it helps you to realize why the net force is 0. So the normal force exerted by my hand and the gravitational force, since we know the net force in the y direction is 0 because we're told it's a constant speed, so acceleration equals 0. So the force that my hand is exerting, and it is a normal force, is just equal to mg. And that makes these lifting problems a little easier. Now what I would need more force to accelerate that, as we learned from Unit 2, and that would be very easy to figure out if we were just told, oh, it's accelerating at this rate. We could just say the sum of the y forces is equal to ma, and I could solve for my normal force that way. So it's not impossible. In fact, it's not even difficult to do it if the object is accelerating. But when they say it's a constant speed, you got to read carefully so that you know that the force applied is equal to mg, and I'll call that a normal force. So our formula for work, and try to be careful that you draw your W for work, which should be capital, differently than you draw your W for weight. Honestly, I wouldn't even use little w for weight. I would use F sub g, and that will eliminate any possible confusion. So my formula for work is equal to the force applied, the distance applied, and the cosine of the angle between them, all multiplied together. So we've decided that the force is equal to the mass of the book times acceleration due to gravity. The distance is given, easy peasy. What's the angle here? Remember, we want the angle between the applied force and the displacement. So back in Unit 2, sometimes we would put an arrow in the direction of motion or in the direction of acceleration or something like that. For work problems, it's often helpful to indicate the direction of displacement so that we can figure out the angle fairly easy. So there's no difference in the angle between my applied force and the displacement, so theta equals 0. The cosine of 0 is equal to 1, so we just have a 1 there. So plugging in the mass, the displacement, and the normal force there, we get 0.98. And I probably should talk about units again. The unit for force is newtons. The unit for displacement is meters. Cosines are just ratios of length, so they're dimensionless. Remember, a Newton meter, we give that a new name, a joule. So 0.98 joules is the answer for sample 7-1.